A very good morning to all of you. Today we are going to learn the Laplace transform. Laplace transform is actually a method to solve the differential equations. For example, here this is a second order linear differential equation in the non-homogeneous second order non-homogeneous equation, especially the ft is a non-continuous function, where in the previous methods for solving the non-homogeneous second-order differential equations, the ft here must be a continuous function, where the ft may be a constant, or a polynomial function, exponential functions, trigonometric functions. If the ft is a non-continuous function, for example, the step functions. For example, your step function, maybe you have this is a step function, maybe you have two different values, 1, 0. Let's say this is 3 greater or equal to 1. This is 3 less than 0. So this is a non-continuous function. The previous technique that you learned, you cannot deal with this non-continuous function. However, Laplace transform can deal with the non-continuous function. So what is the Laplace transform? Laplace transform of function ft is denoted by this symbol, like what we call the L, a special symbol. And then have the curly bracket, stand for Laplace transform for a function ft. By definition, is given by the integral of, this is improper integral because we integrate from positive from 0 until positive infinity. So exponent negative st, where the s is a parameter, then ft. Laplace transform ft, we have the ft multiplied with exponent negative st dt, integrate from 0 to positive infinity. The result of the integral will be a function of s. So we said Laplace transform ft, we get fs, function of s. Noted that when t approaches infinity, exponent negative st ft will approaches 0, because when t approaches infinity, we will have exponent negative s infinity, where the s is a positive parameter. If s, where the s is a positive parameter, then we will have this will be approaches exponent negative infinity. From the graph of exponent negative x, this is exponent negative x, horizontal, this is the x, this is the y. When x goes to approaches infinity, we have exponent negative infinity approaches 0. For example, find the Laplace transform of ft equal to a, where a is a constant, can be any positive or negative value. We look at the first example first. So Laplace transform for a, by definition, will be integral of a here, Laplace transform for a, so our ft is a, so a exponent negative st dt, integrate from 0 to infinity. So we integrate x, where the a is a constant, you can factor out outside the integral symbol, so you have a, and then integrate exponent negative st, you have exponent negative st divided by negative s, so you have negative a over s. And then the limit of integral is from 0 to positive infinity. When you plug in t equal to infinity, we have exponent negative s infinity, which is equal to 0. So minus with the lower limit, minus. So exponent 0, you will have equal to 1. So take in notes that exponent negative s infinity will equal to 0. Okay, that's why negative, we have a over s. So note that we have shown the first case Laplace transform formula, which is Laplace transform for a will be a over s. Hence, if I ask you, let's say Laplace transform for negative 3, then will be negative 3 over s, and so on. Okay, the second one, the Laplace transform for exponent at. By definition of Laplace transform, then we'll integrate exponent, exponent at multiplied with exponent negative st dt, integrate from 0 to positive infinity. Okay, later on, we have exponent negative st multiply exponent at, and we combine it, multiply. We have, let's say, exponent a multiply exponent b will be equal to exponent a plus b. Hence, you add up the index here. So exponent negative s, positive 80, so negative, so this is plus 80. Okay, so mean we combine the exponent negative st, exponent at become exponent negative s bracket s minus at, and then if we integrate this one respect to t, we'll divide by the coefficients here. So divide by negative 1 over s minus a. Again, later on, when we plug in the t by infinity, exponent negative infinity will have 0. And then when we plug in t by 0, so we minus exponent 0 is 1. So negative and negative, hence the result is 1 over s minus a. So again, we have the second formula, Laplace transform for exponent at is equal to 1 over s minus a. Hence, if you want to find, let's say, exponent negative 5t, but so the formula here means a is 5. A is negative 5. Because Laplace transform for exponent at, you have 1 over s minus a. If Laplace transform for exponent negative 5t, where the a is negative 5, so you have 1 over s minus, means a is negative 5. 1 over s minus negative 5, you have 1 over s plus 5. C is the Laplace transform for ft, where the ft is what we call, this is a non-continuous function or a step function, where the first function you have 1 minus t if t from 0 to 1, and ft equal to 0 when t greater than 1. So by using definition of Laplace transform, however, definition of Laplace transform, we integrate from 0 to infinity, but for example 1c here, you have to divide it into true interval, meaning you integrate from 0 to 1, where the ft is 1 minus t. And when t from 1 to infinity, your ft is 0. So integrate 0, you have 0. Hence, you just integrate 0 to positive 1, exponent negative st multiply 1 minus t. That's what you get here. And from 0 to 1, your ft is 1 minus t. From 1 to infinity, the ft is 0. Okay, this one will get 0. Okay, to integrate this one, you notice now we have the, okay, your integral is in the product form of, this is u, okay, in two functions, exponent negative st multiplied with 1 minus t dt. Okay, the product form. You can, okay, in the form of integral u dv. It's either you use a by part formula or we can use the tabular method. If used by part formula, means you have to do it several times, where the integral of u dv will be equal to uv minus integral of v du. Okay, but you have to do it several times. I think maybe several times. So in this case, I will solve it using tabular methods. Okay, for tabular method, if I have a polynomial, I will choose this is to be u. The u is 1 minus t. Exponent negative st dt will be the dv. Okay, here I will show you, okay, the tabular method. We have three columns. The first column is the sign, start from positive, negative, positive. It will be alternate, start from positive. Second column is a u. Okay, if we have polynomial function, normally we choose the u as polynomial function. Otherwise, doesn't matter. You can choose which one as u, which one as dv. As long as u is a function that is easy to differentiate, dv is a function that is easy to integrate. Okay, dv is exponent negative st. For u, you differentiate it if you have polynomial function. You differentiate until we have a 0. So you differentiate 1 minus t, you have negative 1. Differentiate negative 1, you have 0. For dv, you integrate it. Integrate exponent negative st, you have negative 1 over s, exponent negative st. Okay, integrate it second time. So divide again by negative s. So you have 1 over s squared exponent negative st. And the result of your result of the integral of 1 minus t exponent negative st, mean the result integral of 1 minus t times exponent negative st will follow the slanting arrow here, positive 1 minus t multiplied with negative 1 over s exponent negative st, and then here negative, negative, so positive 1 over s squared exponent negative st. Once you can see the result here, which is actually here. This is from the first row. It is negative 1 over s exponent negative st. Okay, negative 1 over s exponent negative st. Then positive t over s come from this term. Negative t, negative 1 over s. So positive t over s exponent negative st. Okay, the third term is from the second slanting arrow. Negative, negative, so positive 1 over s squared exponent negative st here. Then integrate from 0 to 1. So we integrate respect to t, so remember to plug in upper limit 1 into parameter t, variable t. So first term we have negative 1 over s exponent negative s. So this is 1 over s exponent negative s. 1 over 1 squared is 1 over s squared exponent negative s. So minus with the substitution of lower limit where the t equal to 0. Okay, when t equal to 0, exponent 0 you have 1. That's why you have negative 1 over s. So when t is 0, when you plug in t here equal 0, this term will become 0. And the last term, exponent 0 is 1, that's why I have plus 1 over s squared. So remember, this is the upper limit minus lower limit. Okay, and you simplify it. Okay, you get this is the result. So later on, we are going to show, derive the formula for Laplace transform for sin 80. Sin 80. By using definition of Laplace transform, when we integrate exponent negative st sin 80 dt from 0 to infinity. Okay, this is the result obtained by tabular method. Okay, later I will explain how we obtain using the tabular methods. And then integrate from 0 to positive infinity. So again, when you substitute t by infinity, so exponent negative s infinity equal to 0. So 0 times anything, because sin infinity t or cos infinity t, their value is actually varied from -1 to +1. So you multiply by 0, you get the result is 0. Later on, we plug in the t with 0. So exponent 0, we have 1. So minus -1, so become +1. Because exponent 0, we have equal to 1. And then, remember we minus, okay, minus with the substitution of lower limit. So this is, so minus with -1. So you get +1. Okay, later on, when t equal to 0, sin 0, we have 0. Cos 0 is 1. That's why I have a over s squared. Okay, and then, so this one, total we have actually a over s squared. So s squared and s squared here you cancel. That's why you get Laplace transform for sin 80 is a over s squared plus a squared. Okay, go down here first. So we have derived I think the first formula. Laplace transform for a is a over s, for s is greater than 0. Laplace transform for exponent 80 is equal to 1 over s minus a, where the s must be greater than a. Laplace transform for sin 80 is a over s squared plus a squared. Hence, if I say Laplace transform for sin, okay, let's say if Laplace transform for sin 2t, 2t. Okay, so a is 2. Then we just replace is equal to 2 over s squared plus 4. If I say Laplace transform for sin 2t. So a is 2. So replace a here by 2. So s squared plus 4. Okay, just now I promised to show you how you do the tabular method for how you get the result here by tabular method, and how to do the integral of exponent negative st sin 80 using tabular methods. Okay, as I said, if you don't have the product form with the polynomial function, you can choose either one as u, either one and the other one as a dv. In this case, I choose the u as a sin 80. U is sin 80 and sign start from positive, negative, positive, alternate. Sin 80, dv is exponent negative st. And if the u is not polynomial function, that's impossible for you to differentiate until you get the coefficient u here become 0. In this case, you just need to do 3 rows for your tabular method, where the third row you get back the same term. I said term, not coefficient. Sin 80 here, sin 80. Exponent negative st, exponent negative st, then you stop. Okay. So for u, we differentiate. So differentiate sin 80, you have positive a cos 80. Differentiate a cos 80, you have negative. Because differentiate cos, you have negative. Here a, so negative a squared sin 80. So similar with just now, integrate exponent negative st, negative 1 over s, exponent negative st, and then integrate it one more time, become 1 over s squared exponent negative st. Okay, similar with just now when u is polynomial, where the result of the integral is actually the slanting arrow, positive sin 80 multiplied with negative 1 over s exponent negative st. Okay, I erase first, otherwise it's very crowded for you to see. Okay. So here, positive sin 80 negative 1 over s exponent negative st, which is here, where I factor out here negative exponent negative st, so multiply with sin 80 over s. Okay, then this term here. The second one, we have negative a over s squared, so negative a over s squared exponent negative st cos 80 here. Okay, how to get the coefficient here? Okay, because if u is not polynomial function, the last row is impossible to get 0, and the last horizontal row is actually from the by part formula. Remember, you integrate u dv, your result is actually uv, here uv minus integrate of v du. And tabular method is actually a systematical way to do your by part formula, as mean for those by part that where you need to do several times. So minus v du is actually here, the positive negative. So this is v, this is du. Okay, for polynomial function, it's actually this one because this is 0. So minus 0, minus integral of 0 times this one is 0. That's why we just skip this one. Okay, hence we have here integrate of sin 80 exponent negative st dt from 0 to infinity. Okay, the first two terms is actually here, the slanting arrow. Sin negative 1 over s sin 80 exponent negative st here. Negative 1 over s exponent negative st sin 80. Okay, the second term is the second slanting arrow. Negative a over s squared. Negative a over s squared exponent negative st cos 80. Okay, and the horizontal row here, minus integral of a squared over s squared sin 80 exponent negative st here. And this comes from the horizontal, the third row. The integral symbol here comes from the third row here. This one. Negative a squared over s squared integral of sin 80 exponent negative st. This one. The first two rows come from the product of the two slanting arrow there. Okay, and you notice the left hand side, we have one type of integral of sin 80 exponent negative st. Right hand side, you have minus a squared over s squared. This is one type of integral. This is minus a squared over s squared. And you collect it to left hand side. So you have 1 plus a squared over s squared. Okay, this integral that we want to solve. Okay, and 1, change it to s squared over s squared. Okay, you want to find one time of integral of sin 80 exponent negative st dt. So this coefficient will bring to right hand side to become s squared over s squared plus a squared. So this result is what we obtain here. Then similarly, to get Laplace transform for cos 80. cos 80. So you integrate okay, exponent negative st cos 80 dt from 0 to infinity. Okay, by using tabular method, where you can okay do it by yourself and prove it by yourself later on, you'll get okay this result. And then again, when you substitute t by infinity, okay, the exponent negative s infinity you have 0. When you substitute t by 0, you have minus exponent 0 is 1, so mean it minus negative 1, so become positive 1. And then when you substitute cos by 0, cos 0 is 1, so 1 over s. When you substitute t by 0 into sin term, sin 0 is 0. So you have here, which is 1 over s. So s and here cancel, you have the result is s over s squared plus a squared. Okay, how to do it by tabular method and leave it for you to prove it. Hence, now they have shown the first formula. Laplace transform for a is a over s. Laplace transform for exponent 80 is 1 over s minus a. Laplace transform for sin 80 is a over s squared plus a squared. Laplace transform for cos 80 is equal to s over s squared plus a squared. Okay, hence if I said find the Laplace transform for cos 7t. Cos 7t. So just compare here. In a is 7. So you have s over s squared plus 7 squared. Okay, which is s over s squared plus 49. 49. Okay, we have shown 4 formula. Laplace transform for a over s. Laplace transform for exponent 80 is 1 over s minus a. Laplace transform for sin 80 is a over s squared plus a squared. Laplace transform for cos 80 is s over s squared plus a squared. Okay, we're going to show okay, the Laplace transform for hyperbolic sin 80. Laplace transform for hyperbolic sin 80. And as you know that sin 80 is exponent 80 minus exponent negative 80 over 2. Hence, by using definition of Laplace transform for sin 80 will be integral of exponent negative st multiplied by the sin 80 replaced by this formula. So dt from 0 to infinity. And you get half, so you collect this is over 2 exponent negative st multiply. Okay, multiply the first term first. So you have exponent negative s, so negative negative, so this is plus 80. So this is minus here. So exponent negative st, okay, minus 80. So negative bracket negative st. So negative positive a, so negative 80. Hence, you can easily integrate it without using okay, the tabular methods. In this case, no need to use tabular method. Just combine the exponential term using the index formula. So integrate exponent negative s minus a as t respect to t. So half you factor out. So you will have the same term when you integrate or exponent term. You have the same term. However, you have to divide by the coefficient of the t here, which is negative s negative, then this bracket s minus a. And then for the second okay, term, you have exponent negative s plus a, and then you divide this term. So divide, initially you have minus and divide by negative, so become plus s plus a. And then when you plug in t equal to t equal to infinity, exponent negative infinity, you have 0. This one exponent negative infinity 0 means substitution of upper limit you get 0. Okay, and then this is a result of substitution of lower limit. Okay, when you substitute t by 0, so we have actually substitute for the upper limit, the result here you have 0 and then minus with substitution of lower limit. When you substitute t here 0, exponent 0 is 1, so this one we have negative 1 over s minus a. Then plus, the exponent 0 is 1, so 1 over s plus a. So negative, negative, so this is positive, negative, positive, this is negative. Okay. And then, okay, by cross multiplication, 1 multiply s plus a, okay, minus 1 multiply s minus a, then you can combine the two terms here, become s minus a, s plus a will be equal to s squared minus a squared. So s minus s, no more, a minus negative a, 2a cancel with 2, you get a over s squared minus a squared. Okay, first, you notice that Laplace transform for sin at is a over s squared plus a squared. However, Laplace transform for hyperbolic sin, okay, they're just different here. Positive here become negative. So similarly, if I say Laplace transform for sin 8t, so we replace a here by 8, so minus x squared, which is 64. Okay. Similarly, to derive the Laplace transform for hyperbolic cos, you just replace the cos at by exponent at plus exponent negative at. Combine the exponential term using the index rule, right, like just now. So exponent negative s, this is plus at here. And then here plus exponent negative st minus at. So exponent negative st minus at. Integrate respect to t. So first term, you factor out 1 over 2. So integrate this one, you get the same exponential term and divide by negative s, negative and then bracket s minus a. Okay, for second term, you divide by here, negative, this is bracket s plus a. Okay, substitute upper limit, exponent negative s infinity 0. This term also you get 0. That's why 0 here. Okay, we have half, upper limit we have 0 minus lower limit. Okay, for lower limit, when you substitute t here by 0, exponent 0 is 1. So here you have minus 1 over s minus a. So minus minus, here is positive. So for the second term, you substitute 0, exponent 0 is 1. So you have minus 1 over s plus a. So negative, negative, so positive. Okay, cross multiplication, simplified, we have s over s squared minus a squared. You notice that Laplace transform for cos, normal cos, at s over s squared plus a squared. For hyperbolic cos, the plus here look like change to negative. Let's see. Laplace transform of cos 80 s over s squared plus a squared. Laplace transform for hyperbolic cos 80 s over s squared minus a squared. So hence, if I said, okay, Laplace transform for cos 90. So replace a here by 9. It will be s over s squared. 9 squared, which is 81. So we have derived, I think, 6 formula. Laplace transform for a over s. Laplace transform for exponent 80, 1 over s minus a. Laplace transform for sin 80 is a over s squared plus a squared. Laplace transform for cos 80 is s over s squared plus a squared. Laplace transform for sin hyperbolic sin 80, a over s squared minus a squared. Laplace transform for hyperbolic cos 80 is s over s squared minus a squared. Okay, we still have one formula. How to derive, okay, or show Laplace transform for t power n will be equal to n factorial over s to the power n plus 1 for n is 1, 2, 3, and so on. Okay, with this, we can try with Laplace transform for t power 1. Laplace transform for t power 1, using definition of Laplace transform, will be integral of exponent negative st multiplied by t dt from 0 to infinity by using tabular methods. Okay. We have a polynomial. So you just u as a t. Okay, differentiate t, 1, differentiate 1, you have 0, stop here. So sign alternate from positive, negative, positive. dv is exponent negative st. Integrate it first time, negative 1 over s, exponent negative st. Integrate it second time, negative, negative, positive. So 1 over s squared, exponent negative st. And the result will be okay. Let's see. Okay, the result, this is t squared. Yeah. So the result positive t multiply negative 1 over s exponent negative st, where I factor out negative exponent negative st. So it's t multiplied with t over s. Okay, the second result, negative 1 over s squared. So negative 1 over s squared multiply exponent negative st. Okay, the horizontal, if you want to do, this is actually, you integrate positive multiply 0 multiply this integral. Mean the horizontal, so integrate 0 times this one. And 0 times 1 over s squared exponent negative st dt, where this is 0. That's why we just take the slanting row as a result of the integral, because the horizontal here you have u0, so you get this is integrate 0, which is 0. And then you evaluate this one. Substitute t by infinity, exponent negative s infinity is 0, so the whole term becomes 0. Okay, substitute by lower limit, Mean you have actually 0 minus, when you substitute t equal to 0 here, exponent 0 is 1, so negative 1. Negative 1, okay, multiply t0, this will be 0, okay, plus 1 over s squared. So here, negative, negative, so there's a positive 1 here, 1 over s squared. So the result is 1 over s squared. Okay, 1 can be rewritten as 1 factorial. 2 is s to the power 1 plus 1. That's why Laplace transform of t power 1, 1 factorial over s to the power 1 plus 1, which is s squared. Here. Laplace transform of t power 1, 1 over s squared. Okay, 1 is 1 factorial. S squared is actually s. T to the power 1, so 1, n plus 1. Okay, similarly, if you show Laplace transform for t squared using tabular method, okay, this is a result from the tabular method where you can, okay, look through or prove through by yourself. In here, t squared exponent negative st, so differentiate t squared 2t, differentiate 2t, 2, differentiate 2, 0. Okay, so this one we have 3 result of the integration. So this is here, differentiate integrate exponent negative st, first time negative 1 over s exponent negative st, second time 1 over s squared exponent negative st, third time negative 1 over s cubed exponent negative st. And the result, okay, I factor out negative exponent negative st here. And you have t squared over s here. Okay, negative exponent negative st, and then you have 2t over s squared. So I factor negative exponent negative st, and then you have 2 over s squared. So similarly, when you substitute t by infinity, you have exponent 0, exponent negative infinity 0 minus, substitute t with 0 here, exponent 0 is 1, so you have minus negative 1. Okay, substitute t minus negative 1, that's why here you have 1. Substitute t by 0, this term gone, that's why I have 2 over s squared. Okay, 2 over s squared, 2 can be rewritten as 2 factorial. Can be rewritten as 2 factorial. S to the power 3 is s to the power 2 plus 1. Mean Laplace transform for t squared, that's why you have t squared, 2 factorial, s to the power 2 plus 1. Okay, similarly, if you do Laplace transform for t cubed using tabular method, t cubed differentiate second time, first time 3t squared, second time 6t, third time 6, fourth time 0. For dv, you integrate it and you have 1, 2, 3, 4, 4 result of your integral. And I factor out negative exponent negative st here. So for the first result, you have t cubed over s. Second result, you factor negative exponent negative st. So 3t squared over s squared here. The third one, 6t over s cubed. The fourth one, 6 over s power 4. Yeah. Then you substitute by upper limit t by infinity, exponent negative s infinity 0. Substitute t by 0, exponent 0 is 1, so negative 1. Okay. Later on, substitute t here by 0. So this is 0, this is 0, this is 0. You have 6 over s power 4. 6 is actually 3 factorial. 3 factorial means 3 times 2. find 1. S power 4 is actually s to the power 3 plus 1. So you notice that Laplace transform for t power n factorial over s to the power n plus 1. So mean Laplace transform for t n is 1, so you have 1 over here 1 plus 1 2. Okay, if Laplace transform for t squared, here t squared, so replace n here by 2. 2 factorial is 2. So s to the power 2 plus 1, so s cubed. Okay, Laplace transform for t cubed. T cubed 3 factorial 6 divide by s to the power of 3 plus 1, s to the power of 4. Okay, then if you want, let's say if you want, this is Laplace transform for, let's say, t power 5. So you have 5 factorial s to the power of 5 plus 1, 6. So 5 factorial is, okay, you have 5 times 4 times 3, okay, times 2 times 1 divide s to the power of 6. So 3 factorial is 6, 4 factorial is 24. 24 times 5, you get is 126 over s to the power of 6. Okay, so in conclusions, okay, we have learned that Laplace transform for a is a over s. Laplace transform for t power n is n factorial over s to the power n plus 1 for positive n, positive integer value. You don't have the fraction number, positive integer n value only. Laplace transform for exponent at is 1 over s minus a for s greater than a. Laplace transform for sin at, we have is a over s squared plus a squared. Okay, Laplace transform for cos at is s over s squared plus a squared. Okay, Laplace transform for sin hyperbolic sin at is a over s squared minus a squared. Different with the normal sin this is plus. Laplace transform for cos at is s over s squared minus a squared. Different with a normal cos is plus. Okay, here, thank you for your attention.